Is it on? Great. Thanks everybody for being here. What an amazing conference. We all, I think, had a massive blast until so far, and let's see what happens. I hope we will survive this. There's some electricity involved, and I saw there's a fire extinguisher over there, so I think everything is going to be fine.
So, let's get started.
Yeah, maybe let's quickly just have an introduction. My name is Nikolai Onken. I'm from Germany, living in Amsterdam, from Uxibu. And basically, I got involved with this whole Arduino controlling hardware with JavaScript last year at JSConf. Then we just had the idea, hey, we have PhoneGap, we have mobile devices, but we don't have any APIs to control hardware, and that's really what we should be able to do. So I've set up this Bluetooth setup so you could talk to the Arduino via Bluetooth. That kind of was very unstable, so now we do kind of USB cable-ish things. That's about me.
Yeah. So I'm Jörn Zaefferer. I'm from Cologne in Germany. I've been here last year, presented about jQuery, but as we figured out that all the JavaScript frameworks that run the browser are kind of boring now, we decided to focus on something more fun. And apart from the Arduino stuff, which Nikolai proposed as a talk, was the idea of trying to find some examples that are really easy to reproduce. So basically, everyone else can try these out too, and we'll get to these very soon. But for now, let's talk about our mission.
Yeah, so this will be the introduction before we start the hacking action. We have a mission, and our mission, everybody knows this, is, of course, it's a bit slow, but JavaScript to rule the world. Right?
As Douglas deduced tomorrow, if there can be one language to do that, it should be JavaScript.
I mean, browsers. We need much more than that.
Yeah.
So first, there was Mosaic, long time ago. That's how it all started. Then for a long time, there was nothing. Nothing happened, as we all know. And now we have robots. And that's what we want with JavaScript. There's a little hook to the action, so to say.
Yeah, unfortunately, our robot became sentient, and we had to shut him down in order to prevent a future Skynet. He
was afraid of all those drinking people here.
Yeah.
So we really actually are that far. But I mean, it's the first step. We can now turn off stuff, turn on lights, turn off lights, open doors, and whatever. And really, with the Arduino, you can do much more. But right now, that's how far we are. So that's really all the slides we have, and the rest of this will be kind of like a Sendung in der Maus, Sendung mit der Maus. It's like a German TV show. Bastelstunde.
Yeah. So let's switch this.
So we need some people. We made this couch here. You see, it's very comfortable. And we need Holger, Malte, and Chris. Where are you? There you are. We're going to do some experiments with these guys.
Where are the helmets?
First of all, give all of them a huge applause for setting all this up. Amazing, really cool.
Put them on the power.
All right, so to start off, we've got something that is really safe and easy to reproduce. It involves this WebSocket, which includes some software with the web server. So we can actually control this web server over HTTP. 3 of these sockets contain relays, so we can switch them on and off. Basically, I've got this little Node.js proxy, which excludes an HTTP client to access the socket and includes the web server, so we got our own UI here. See if this is still working. Nope. I need to restart the server.
Robots. Robots.
All right, and we've got the net control JS. So to start off, I think we need some lights. And nothing's happening, so let's see.
Is it connected?
we'll get there. So let's see. The web interface
right?
is still working. Nope.
It's plugged in.
So we can't reach the socket, so something there doesn't work as intended. Let's just have it reconnect.
So in the meantime, we really wanted to bring a real blender, you know, like to make actual drinks.
And here we go.
This is what we have. And this, it's almost there. This is going to be the blender for making drinks today. I won't turn it on here, I promise. It's actually going to be turned on there.
Okay, now it should actually be working. Let's see if it does. To start off, some...
Oh! Party!
Next up, some music. Let's see if that... I've got this really cheap radio clock here. That must be good enough. And now to get to this important part.
How much do you want?
So
fill it up a little bit.
Long way to go to automate that as well. But for now, it's turned on already, and I'm going to hit the switch. Good, good. Come on.
It's foaming. Amazing.
Okay, I think that should be enough. Okay, time to get drinking. Can you do this?
Is this for Chris? extra.
Okay, now we've got, yeah, that's the winner for the next contest. We keep this.
Yeah, this is for you guys.
So.
Oh, we have 4. Anyone?
Yeah, no.
Anyone? Peter. There you go.
Okay, so let's.
Yeah, you can drink it now, and then we'll do some more experiments.
Shitty music for now, but we'll leave on the disco light, of course. Next up is the Wiimote. This is just a normal Wiimote. You can get it at any store for 40 euros, so really cheap to get started with some of these experiments. And most computers include Bluetooth support. So Bluetooth can be a bit annoying to get connected to, but let's see if I can put that so you can actually see it. I've got this extra software which makes it a bit easier to connect it on Windows. Once you actually set it up once, it's really easy to connect it again. So just select the connect option here, press 1 and 2 buttons, and it'll blink a bit. And then a dialog should pop up which says a bit, okay, it's now displayed here, but it's now connected. So it's continuous blinking for now, because it doesn't know what to do otherwise, but we'll make it do something. So what I've built here is, I should have cloned the monitors instead of extending it anyway. So we've got this little command line tool. We'll get to the actual code for that in a minute. Once that is started, I've got this script here. It'll display a bit of blah blah, start a countdown, and now the script is running and I can shake it, and for 5 seconds I can try to get a high score. So
finish those drinks and then we're going to play this game.
The axis it reads is the x-axis, so you actually have to shake it that way. And the idea is to make a contest, and we'll see who can get the best score here. You can stand up if you want, so that you don't hit anyone. And you've got a countdown of 3 seconds, so when it says go, it's actually reading your movements.
Go, let go!
Oh,
33, very good. Let's see. Next up.
3, 2, 1, go!
Hey. Okay, that looks like actually.
I gotta get into position.
And 3, 2, 1, go!
That's awesome.
No, that's great. Give me a sec. If you, it's not off because if you start with the 1, and once it's going, it'll actually animate the LEDs so you can see that you did.
Should Chris get another chance? Yeah.
They give you another chance. You have to check on the x-axis. No, it's off. Very good job.
Good job,
Okay.
good job.
I think Marta wins this, Holger wins this round with 33 points, though Chris gets bonus action for. No, I think he won 29. Chris gets extra points for crashing the JVM. So you actually now know what's running this stuff. So let's take a look at the code for this little game. And before we get to that, I've got one slide for this. So this stack actually consists of a few elements. We've got a C library to connect to the Wiimote via Bluetooth. So there's the Windows Bluetooth stack and the C library to connect to that. So that would be a good candidate to actually create a binding for Node.js. We don't have that yet, but it should be, if you actually know a bit about that, it should be fairly easy. Then there's a REPL library in Java for using the C library for the Wiimote in Java. And as we've got that already, I'm using Rhino to run JavaScript to access Java library, to access C stacks, and access the Wiimote via Bluetooth. And then I wrote a bit of mock jQuery API in order to script the Wiimote just like you would script with jQuery, wherever it's actually running. And this demo, well, you've seen what it does. So let's look at a bit of the code. So this file actually includes both a bit of infrastructure code and the actual game, can say so. It's all on GitHub already. So this is the part that handles the actual motion. Selects the Wiimote, binds a motion event, then wraps the raw Java Wiimote object in order to get this pseudo jQuery object. This starter variable is set somewhere else. We'll get to that in a second. And then it just checks if the event has a raw acceleration on the x-axis over 240. So that value probably goes up to 255, and anything above 250 is basically impossible to reach. You can't check as much as you want, it doesn't happen. So this is close enough to actually make it sort of difficult. And then basically just counts, logs out the counter, you didn't see that, and then sets on the LEDs on the Wiimote, and then use this little helper to basically animate them off again. So every 150 milliseconds, one of these is executed, so that you can actually see if you made the right move, and then it'll animate them off unless you continue checking. So the countdown starting the script is here. Use the same stagger method with 1 second delay. And then for exiting the game, another timeout, turns off the LEDs, outputs the finishing score, and exit the event loop, which gets started at the last. So I've scripted a bit of infrastructure here, which basically imports a few stuff from Java packages to work with, fakes the console log object to map to the Rhino print line, creates a little set timeout method, and also for clearing and checking timeouts, and then finally does a custom loop, which you probably wouldn't have to do in Node.js because Node always includes the actual loop. But this basically just makes a thread sleep after 15 milliseconds, then sees if there are any timeouts, and due to the Java library for the Wiimote, it will actually trigger the events. So we can take a look at the actual mock jQuery API, which is really just a mock. It doesn't include any actual jQuery code. If the selector equals Wiimote, the string, we use API manager to get the Wiimote. If it can't find any, it'll just return an empty object, so just like jQuery would. If we pass an actual Wiimote object, it'll basically use that as a selector, and then it returns a method, an object which includes these two methods, bind and the LED method below here, which basically just forwards a method calls to the Java objects, while the bind method for now just checks if the event is anything other than motion, because we don't support that yet, and then returns. Then there's a bit of stuff here on the status event method to display the battery level just once. Also adds buttons event so that if you press the home button, it'll exit. And then the actual interesting stuff on the motion sensing event, which basically maps just Java interface here. It'll use the callback that the user provided and pass along a new object, mapping, again, the Java object to this more useful JavaScript object so that we don't have to call method to just access these fixed properties. And then just get status one so that we can actually output the battery level. Yeah. So next step would be to bind the Java API, the C API for Wiimote access to Node.js, so that you can use, basically rewrite this in Node.js, maybe reuse even actual jQuery code. And that's for the Wiimote stuff.
All right, so we need to switch a couple of things.
What?
Oh.
Let's move that somewhere else.
Did you drink? No.
Not yet, not enough.
Okay, so who of you knows the Arduino board? Nice, that's really cool. So we all could just build some stuff actually right now. I was just on the website of Arduino, and they actually are releasing a new board today, which is pretty cool. I don't know what the specs are. I assume it's going to be a lot more interesting than what we have right now. But anyway, so what I have here, it's a little bit small to see, but here, kind of dangerous prototype, where I have the Arduino board, which is connected to a serial connection to the laptop. And then the Arduino is driving a relay. And the relay is then triggering 220 volt to turn off or turn on lights. So I'm gonna, this is the dangerous part now. Hold your thumbs, everybody. So I'm gonna show first, I'm just gonna show the demo first, and then I'm gonna explain what actually is happening there. So here I have my iPad connected to the network. I have a little interface which I can use to trigger the different pins on the Arduino. And now if I trigger it, if you listen really well, I'll be quiet, you hear the relay switching. Can you hear that? Yeah. Oh, okay. So this works, and now I'm going to connect the wish me luck. Yeah. I'm going to connect this disco light to the power. Can we turn down the light a little bit? Because of course we need some music before we do disco action. I'm going to turn on sound now, so. So I'm just going to give the iPad a round. You can only hit the first button, the round one. Is it working? Yeah, no, like hold it. Yeah.
This is VJ.
Nice. You're a really good VJ. Amazing.
Triggered really fast. It's quite responsive.
If the latency is super low, it's amazing. He's a talented. Yeah. Anyways, I'll just keep it, you can just pass it around, and I'm going to explain how this stuff works.
Yeah.
Okay. Yeah. Okay, so basically just to run through what's actually happening, I have the Arduino here. It's connected to a serial connection to the laptop. I'm running Node on my laptop, and the really amazing serial Node module written by Chris. It's totally working. I'll show the source code in a second, and it's for a JavaScript developer, it can't be any easier to do all this kind of stuff. So I'm using the serial connection, and then Toby Taylor, he's somewhere here, up there, he started to write Arduino JS, which is basically sort of mimicking the APIs we have on the Arduino, which we would have to write in C, to JavaScript. So we can actually use the same APIs in JavaScript and say something like analog read or analog write, and then it's mapping it to the Arduino. So here you see my app home control. Let's start from the Arduino side of things. Basically what we have here in the loop, we're reading the different opcodes we're receiving to the serial connection, and basically just triggering digital write, digital read, analog write, analog read. And we could extend this to much more things. Right now it's very simple. We can, as I said, we can just turn things on and off. But there's much more we could actually do to get stuff running. So this is the Arduino side of things. You just compile the code, upload it to the board through USB, and then you're ready to roll from the board side of things. Now, here we have the Arduino JS, which basically does exactly the same thing, but in JavaScript. So here you see our opcodes, which are triggering the different functions. And then here you have basically, I mean, if you compare it, it's almost exactly the same. So in JavaScript, I can say arduino.pin mode, and then it triggers the pin mode function on the Arduino itself. The thing now is we're running Node, and I want to have the same API in the browser. So this JavaScript here is used both by Node and by the browser. Now Node is connecting to the Arduino through the serial connection. So here I have a sort of, I called it a provider, it's maybe not the best naming, but here you have the serial provider, which basically is using the serial module by Chris. And really, if you look at the code, all we do is we require serial port native, and then literally all you have to do is you have to provide the path to the USB device, and then in JavaScript, this is your line of code you have to write to connect to a serial device, which is amazing. I mean, in JavaScript, this is exactly what we want to do. We don't want to be nice. We don't want to write any more low level than that. And if it works like this, this is just perfect. It makes it really easy to get started with these kind of things. So now we're in Node. Node is creating the connection to the Arduino with the serial provider. On the front end side of things, I'm connecting to the Node instance through a socket connection. And there, basically, again, all I do is one line of code almost. io.socket, that's it. And then if I show the actual JavaScript code of the little interface, I have there, I'm instantiating a new board, Arduino connect. I connect to the Arduino board, and then I'm just calling board.digitalWrite. I provide the pin, which I want to talk to, and the action I want to do. So turn on or turn off. That's it. Exactly the same API as we would have on the Arduino. And I can just show it here. Chrome crashes with WebSockets sometimes. So I can trigger it, and you can trigger it at the same time from the iPad, which is pretty cool if you think about it. I mean, the use case is very basic, and we can do much more. You can drive servos with the Arduino, motors, whatever, all kinds of things. So there's huge potential of what we can do, really.
Can you access this from any clients?
Yes. If you have a mobile phone right now, and if you would connect to my network, you could just now also open up it's 10.10.021. Yeah. Dot source. No, what is it? So we can actually try it. The network is www.test, Let's see if we can burn this down. So, so if you connect with your iPhone or whatever to www.test, and then the IP is 10.0.2.1 git, what is it? Oh, Arduino JS. Apps, I think. Yeah, home control. Static. There you go. So if you put this into your phone, anyone is trying it? Okay, I should have made it shorter, the URL, but. Who was that? Nice. Oh, no, that's not going to be good. Hold on. Not short. We could attach it to a laser. Oh, I don't have, oh, I'm not on the internet, of course. Yeah, yeah. So you can literally build any kind of apps controlling hardware. And of course, this is like prototyping, and this you wouldn't really use this at home unless you're crazy a little bit. But if you think about it, you can actually build hardware now and control it with JavaScript. And that's something which is very exciting, I find, because we're just getting into a whole new sort of area of JavaScript development, which we haven't really done before. Did anyone else connect to it? Did it work? Oh, cool. Yes, someone is blocking. Yeah. Okay, so just a few more info if you want to get started. We actually have a couple of boards here, and I think it would be really, really cool to solder a JSConf logo using LEDs, and then make it blink or whatever with a nice interface. Maybe we can do it later, we can see. But basically, if you want to get started with the Arduino, just check out arduino.cc. It's a really cheap board. It's like 30 euros or something. You can order it online and then just get started right away. Node Serial is on GitHub, so you can just plug that into your Node instance and then get rolling with that. We use Socket.io, awesome for the socket work, and that's basically it. Really, it took a couple of days or a couple of hours really to actually put everything together. The biggest challenge was the 220 volt kind of part, because that was a bit scary and you don't really want to play with electricity, I think. The source code for Arduino.js is on GitHub as well. You can just fork it and extend it and just try it out. It makes it super easy to start doing these kind of things, basically. So, yeah, I mean, we need some pie charts, of course.
Some pie charts.
So in 2009, at the JSConf in DC,
it was basically all client-side JavaScript, jQuery Dojo and whatever. So we've got moved on a bit. Last year here in Berlin, we already got much more server-side stuff, especially with Ryan and his amazing Node.js talk. This year in Washington was more like 50-50. And now we try to introduce at least some embedded
yes.
stuff. And we hope to be the start of getting to even more of that.
So next year we totally want to see robots. I mean, this year we were turning stuff on and off, which is really cool. But next year we need to like steer robots with our mobile phones and everything in JavaScript. So yeah, as I said, we have a whole bunch of stuff here. We have a soldering iron. If anyone really wants to start soldering some stuff, we can do it. LEDs and everything. If anyone actually knows how to do electric stuff, because I actually don't really know it, I was just putting the cables together, would be a great help, I think. So yeah. That's basically it.
Yeah. So thanks for listening.
Thanks. Do you have any questions?
Crazy.
Any questions about the stuff? Okay. Nice.
Great.
Any other questions? Could you repeat that? Absolutely. I mean, you can do it. There's a whole bunch of libraries for the Arduino, which you can use. Actually, I set up Bluetooth as well, so you can just connect from your phone directly to the board through Bluetooth. It's just really unstable because it's a jailbreak device.
The next Arduino will also get Ethernet connection directly onto the board and an
Okay.
SD card. So yeah, I think you can totally do this. There's also a nano version of this. This is like talking about.
So if you actually want to build a home network with sensors that are connected over the wireless, there's two protocols, Zigbee and Z-Wave, that may be interesting to look at. Both have some weaknesses. Zigbee is an open standard, Z-Wave is not, but the hardware is a bit cheap. But that may be something to look at and look for how you could actually interact with JavaScript with these mesh protocols. Because the interesting thing there is that you can add standards here and there, and the range from my controller to the last standard would be too long, but they can connect using other nodes in the network without actually other access points, which is really interesting for stuff like that.
Any more questions? All right, thanks. Enjoy the conference.
Thank you very much.